Hey everybody, Professor Corey and Professor Victoria here. We are the Professor's Stew Boys, and today we're going to be talking about partial pressure of gases.
All right, Dalton's law of partial pressures states that the pressure of a mixture of gases is equal to the sum of the pressures of the individual gases. So what this means is that it doesn't matter what gas it is, we can just add the pressures. So you can see here we've got oxygen, nitrogen, and hydrogen. We have 0.5 atmospheres hydrogen, 0.8 nitrogen, and 0.3 hydrogen. The total pressure is just going to be the sum. This is real easy. We just add the three. So we can say that the total pressure is equal to the sum of the individual pressures of the gases in the mixture.
Mole fraction. So this is a new term and a new concept for us. Mole fraction is something that we use with gases to determine the partial pressure or the pressure for the individual gases. And the total pressure of a mixture of gases is directly related to the number of moles in the gas. So I didn't say masses, just moles. Number of particles is what drives the pressure. So that if you have 25% of gas molecules in a mixture, that will create 25% of the pressure. Identity doesn't matter.
So when we calculate the mole fraction, we represent it with a capital X, and a lot of times subscripted will be the name of the gas. So if we were looking at nitrogen gas, it might be a big X with a little subscript N2. And what this is that would be the moles of the nitrogen gas divided by the sum of all the gases in the mixture. And I like to think about this as it's almost like doing your test grade. So you take the number of questions you got right divided by the total number of questions. Very similar to this. Now with the test grade, we'll multiply by 100 to get a percent, and we don't do that here. We leave it as a decimal, but we could figure out the percent simply by multiplying by 100. So in this example, we have half a mole of oxygen in a mixture where the total amount of all the gases is 2 moles. So the 0.5 divided by 2 is 0.25. That's the mole fraction of the oxygen in this mixture.
So mole fraction is a unitless quantity. So we have moles divided by moles, and they cancel, and you end up with a unitless quantity. Oftentimes, we don't have that with the values that we're using in chemistry, but this one is. And the sum of the mole fractions has to be 1, right? So just like percentages, if you add up all your percentages in a mixture, it would equal 100. If you add up all your mole fractions, they will all be decimals. If you do it right, they will total 1.
So let's take a look at this problem. We've got the partial pressure of oxygen. To calculate the partial pressure, we're going to take the mole fraction of the oxygen and multiply it by the total pressure. So this is the total pressure of the mixture. And that will give us the pressure that oxygen contributed to this. So if the mole fraction was 0.25 for the oxygen, like the example before, and the total pressure of the mixture was 4 atmospheres, we would simply multiply the 0.25 by the 4, getting 1 atmosphere, and that's the contribution that the oxygen has to the mixture.
We call that partial pressure. All right, so here's an example that you might come across. So we have a cylinder of compressed gas, and we have percentages by mole of H2S, carbon dioxide, and nitrogen. And the question is asking, what's the partial pressure or the pressure due to each individual gas in that tank? And it gives us a total pressure of 46 atmospheres. So we need to convert the percentages to mole fractions. And we have the mole fractions here. So if you have a percentage of 4.5, you can divide that by 100 and get that decimal percent. And so we did that for each of these. Now notice for the nitrogen, we calculated it, or we just brought it down for the H2S and the CO2, and the balance was nitrogen. It didn't give us that percentage for nitrogen. But since all the mole fractions add up to 1, we can just simply subtract from 1 to get the mole fraction of nitrogen. And you can add those 3 up, and they should total 1. All right, so to get the partial pressure then is, remember back to our formula, the mole fraction times the total pressure will give us the partial pressure due to that individual gas.
So a good check when you're done is you could, if you were calculating partial pressures, you could sum the partial pressures and they should equal the total pressure.
Right.
It's just a good check.
Good tip. All right, you want to talk through this one?
Sure. So we've got a mixture. We have 3 different gases in the mixture and they gave us the total pressure. They gave us the partial pressure of the krypton at 1.15 atmospheres. This is less than the total. This makes sense. And if there's a total of 16.5 mole of gas present, what amount of Kr is present? So what this is saying is that if we combine the helium, the xenon, and the krypton, there's a total of 16.5 moles. So we know the partial pressure, so we can use that partial pressure of the krypton to find the mole fraction of the krypton. And then from there, we can determine the amount in moles or grams if we wanted to go that far. So let's back up a little bit. I've got the partial pressure of the krypton, that's the 1.15, times the mole fraction. See the X with the little Kr subscripted there? So that's saying that's the mole fraction of the krypton times the total pressure, that's the 2.46 atmospheres. So solving for the partial pressure, I get 0.467 grams, or 0.467 unitless,
Right.
I should say. I can't advance.
Okay. I can.
Okay, so what is this mole fraction? Well, it's the moles of the krypton over the total number of moles, right? That's the definition of the mole fraction. And oftentimes it's good to go back to, what does this mean? What is mole fraction? I solved for it, but what does that mean? Because this really helps us now, because we're like, oh wait, I have the total number of moles. I can put that in, 16.5, and then I can solve for the moles of krypton. I could go from moles to grams if the question asks for that.
Okay, so here's your practice. Take a moment and pause the video and give this a try.
I think this is going to be rather challenging, actually.
It's a good one. We'll walk you through it, but we won't give it away yet. Okay, so this is kind of interesting. So you need to calculate the total pressure first. So this combines the ideal gas law with partial pressures. So we're in the gases unit. So you've already learned the ideal gas law. So we have the temperature and we have the volume and we have the moles. So you have to total the moles first, put that into the ideal gas law, solve for the total pressure, and then you can determine the partial pressures with your mole fractions.
Tricky question.
It's a good one. Oh, and how cute are these girls? I just love it. We hope that you can be as excited about chemistry as these little girls are showing you, and come back to the Professor Stu Boys channel and learn more chemistry where you matter. Have a good night or day.